You're sitting on the couch, maybe watching TV or reading a book, and you reach for a chocolate bar. You peel back the wrapper, and there it is. A grid of neat, precise lines running across the surface, dividing the bar into perfect little rectangles. Without even thinking about it, you snap off a piece along one of those lines. The chocolate breaks cleanly with a satisfying crack, and you pop it in your mouth. It's such an automatic action that you've probably done it hundreds of times without questioning why those lines are there in the first place. They seem obvious, right? They're just there to make the chocolate easier to share and eat in smaller portions. But here's what most people don't realize. Those grooves aren't random, and they're not just about convenience. They're the result of careful mathematical calculations, psychological research, manufacturing engineering, and decades of experimentation with human behavior. The pattern of lines on a chocolate bar involves geometry, portion control science, structural mechanics, and even a bit of marketing psychology. What looks like a simple grid is actually a sophisticated design that balances multiple competing factors, and different chocolate companies have developed different solutions to the same fundamental problem. Let's break it down. First, let's talk about what those lines actually are and how they work. The grooves on a chocolate bar are called break lines or score lines, and they're molded directly into the chocolate during manufacturing. They're not cut or stamped after the chocolate solidifies. They're formed as the liquid chocolate cools in a mold that has raised ridges built into it. These ridges create valleys in the surface of the chocolate, and these valleys serve a specific mechanical purpose. When you try to snap the chocolate, you're applying a bending force that creates tension on one side of the bar and compression on the other. The grooves concentrate that stress at specific points, creating what engineers call stress concentration. This is the same principle we talked about with airplane windows, but in this case, we actually want the stress concentration because we want the chocolate to break. And we want it to break in a predictable, controlled way along predetermined lines. The depth and shape of these grooves are precisely engineered. If the grooves are too shallow, the chocolate won't snap cleanly, and you'll end up with jagged, irregular breaks that leave crumbs everywhere. If they're too deep, the pieces might break off accidentally during shipping or handling, or the chocolate might be structurally weak and crack in the wrapper before you even open it. Chocolate manufacturers have found through extensive testing that the optimal groove depth is typically about 1/3 of the total thickness of the bar. This provides enough stress concentration to make breaking easy, but not so much that the bar becomes fragile. The shape of the groove matters too. Most are V-shaped or U-shaped, with the exact profile designed to guide the fracture path precisely along the intended line. Now here's where the math comes in, and it's more complex than you might think. The pattern of breaking lines on a chocolate bar isn't arbitrary. It's designed to solve a mathematical puzzle. How do you divide a rectangular bar into pieces that are the right size for eating while maximizing the number of pieces you can get from a given amount of chocolate, while also making sure the pieces are easy to break off, while ensuring the pattern looks aesthetically pleasing? This is actually a problem in discrete geometry and optimization. Let's start with the most common pattern: a simple grid of rectangles. If you have a chocolate bar that's, say, 10 centimeters by 20 centimeters, you could divide it into 20 pieces by creating 4 rows and 5 columns. That gives you pieces that are each 2 centimeters by 2 centimeters, which is about the right size for a single bite. But you could also divide it into 15 larger pieces, or 30 smaller pieces, or any number of other configurations. Chocolate companies have done extensive research into portion sizes, and they've found that there's a psychological sweet spot. If the pieces are too small, consumers feel like they're not getting enough chocolate and might eat more pieces than they intended. If the pieces are too large, they feel guilty about eating such a big portion and might eat less overall or avoid buying the product. The ideal piece size for most consumers is somewhere between 5 and 10 grams, which translates to roughly 2 to 3 centimeters on each side for a standard thickness chocolate bar. This size feels substantial enough to be satisfying, but small enough to not feel excessive. It's also about the right amount to melt pleasantly in your mouth without being overwhelming. But here's where it gets mathematically interesting. Not all chocolate bars use a simple rectangular grid. Some use more complex patterns, and there are good reasons for this. Take Toblerone, for example, the Swiss chocolate bar with the distinctive triangular shape. Toblerone isn't divided into rectangles at all, it's a series of triangular prisms joined at their bases. This shape is incredibly difficult to break cleanly because there are no straight break lines running all the way across the bar. Instead, you have to twist and snap each triangular piece individually, which actually serves a marketing purpose. The difficulty of breaking Toblerone makes the experience more memorable and distinctive. It's branded inconvenience that creates product recognition. The triangular shape also maximizes surface area relative to volume, which means more of the chocolate is exposed to the air and your taste buds, potentially enhancing flavor perception. Other chocolate bars use diagonal break lines instead of straight ones, creating diamond or parallelogram-shaped pieces. This isn't just aesthetic, it's actually more efficient mathematically. When you break chocolate along a straight line that runs perpendicular to the length of the bar, you're creating a bending moment that requires force from both sides. But when you break along a diagonal line, you can use a twisting motion that's often easier and more intuitive. The diagonal pattern also tends to produce less crumbling because the break propagates along a longer, more gradual path rather than trying to snap straight through the shortest distance. Some premium chocolate makers use this pattern specifically because it results in cleaner breaks and a more satisfying tactile experience. There's also fascinating mathematics in how chocolate bars are designed for sharing. A standard chocolate bar might be divided into 12 pieces arranged in a 3x4 grid. This number isn't random. 12 is highly divisible. You can share it equally between 2, 3, 4, 6, or 12 people without cutting any pieces. This is why you see numbers like 12, 15, 20, and 24 appearing frequently in chocolate bar designs. They're numbers with many factors, which makes equal division easy. Some chocolate companies have experimented with prime numbers like 17 or 23 pieces, but these products tend to sell poorly because consumers subconsciously recognize that they're difficult to share fairly. There's actually published research in consumer psychology showing that products with highly divisible quantities are perceived as more valuable and socially appropriate, even when the total amount of product is identical. The manufacturing process for creating these break lines is surprisingly sophisticated. Modern chocolate production uses precision-machined molds made from polycarbonate plastic or stainless steel. These molds have raised ridges that create the grooves in the chocolate, and the dimensions of these ridges are controlled to tolerances of hundredths of a millimeter. The chocolate is deposited into the molds at a specific temperature, usually around 30 to 32 degrees Celsius for milk chocolate, through a process called tempering. Tempering is critical because it controls how the cocoa butter crystallizes as it cools, which affects the chocolate's texture, snap, and appearance. Properly tempered chocolate has a glossy finish and breaks with a clean, crisp snap. Poorly tempered chocolate looks dull, feels grainy, and tends to crumble rather than snap cleanly. After the chocolate is deposited in the molds, it goes through a cooling tunnel where the temperature is carefully controlled. The cooling rate affects how well the chocolate releases from the mold and how cleanly the break lines are defined. If the chocolate cools too quickly, it can trap air bubbles or develop internal stresses that cause unwanted cracking. If it cools too slowly, it can bloom, developing a white, dusty appearance on the surface. The entire process, from liquid chocolate to finished bar, takes about 20 to 30 minutes in a modern factory, and quality control systems inspect every bar to ensure the break lines are properly formed. There's also a structural engineering aspect to chocolate bar design that most people never consider. A chocolate bar has to survive a fairly rough journey from factory to consumer. It gets packaged, stacked in boxes, loaded onto trucks, shipped potentially hundreds or thousands of miles, unloaded, placed on store shelves, picked up by customers, and carried home. During all of this, it experiences vibration, temperature fluctuations, pressure from other products stacked on top of it, and occasional drops or impacts. The break lines have to be deep enough to make snapping easy, but not so deep that the bar breaks apart accidentally during this journey. Engineers actually test chocolate bars in vibration chambers and climate-controlled environments to ensure they can withstand typical shipping and storage conditions without spontaneous breakage. The thickness of the chocolate bar also plays into the mathematics of breaking. Most standard chocolate bars are between 4 and 8 millimeters thick. This thickness is chosen for several reasons. It's thick enough to provide a substantial mouthfeel and allow proper melting characteristics, but thin enough that you can easily bite through it without jaw strain. It's also thick enough to be structurally stable during manufacturing and shipping, but thin enough that the grooves can be effective at concentrating stress for clean breaks. Some premium chocolate bars are thicker, sometimes up to 15 millimeters, but these usually have deeper grooves or different breaking patterns to compensate. Different types of chocolate require different groove designs because they have different mechanical properties. Dark chocolate is generally harder and more brittle than milk chocolate because it contains less fat and more cocoa solids. This means dark chocolate bars can have shallower grooves and will still snap cleanly. Milk chocolate is softer and more plastic in its behavior, meaning it tends to bend slightly before breaking, so it needs deeper, more pronounced grooves to ensure clean fracture. White chocolate is even softer because it contains no cocoa solids at all, just cocoa butter, sugar, and milk solids, so white chocolate bars often have the deepest grooves or use thicker bars to maintain structural integrity. There's also an interesting historical dimension to chocolate bar design. Early chocolate bars in the 1800s and early 1900s didn't have break lines at all. They were solid blocks that you had to cut with a knife or just bite into directly. The first chocolate bars with molded break lines appeared in the 1920s, and they were considered a major innovation in convenience. Before that, chocolate was often sold in large blocks meant for cooking rather than eating directly, or in individually wrapped pieces like bonbons. The scored chocolate bar represented a middle ground, a single package that could serve multiple people or provide multiple servings for one person, without requiring any tools or creating multiple small wrappers. Some chocolate companies have gotten creative with their breaking patterns as a form of branding. Ritter Sport, a German chocolate company, makes square chocolate bars divided into 16 smaller squares in a 4x4 grid. Their slogan is Quadratisch, Praktisch, Gut, which translates to square, practical, good. The square shape is their distinctive trademark, and the 4x4 grid is instantly recognizable. This shows how break-line patterns can become part of brand identity. Similarly, Cadbury Dairy Milk bars have a distinctive pattern with relatively deep grooves and a specific ratio of pieces that consumers associate with the brand. There's even psychology involved in how people break and eat chocolate. Research has shown that the act of breaking off a piece creates a sense of portion control that makes people feel better about indulging. When you eat a whole candy bar without breaking it, you're consuming it in one continuous action that your brain doesn't really count as stopping. But when you break off pieces one at a time, each break represents a decision point where you could choose to stop eating. This makes people feel more in control and less guilty. Chocolate companies are well aware of this psychological effect, and they design their break lines to encourage this behavior. The easier it is to break off a single piece, the more likely people are to eat the chocolate in a controlled, satisfying way rather than devouring the whole bar at once or feeling frustrated and breaking it into irregular chunks. Some experimental chocolate bar designs have tried to eliminate break lines altogether, using other methods to control portions. There have been chocolate bars with perforated wrappers that guide you to tear off sections, chocolate bars with individually wrapped pieces inside a larger package, and even chocolate bars with printed lines but no actual grooves, relying on visual cues rather than mechanical weakness. None of these alternatives have been as successful as the traditional molded grooves, which suggests that there's something psychologically and physically satisfying about the tactile feedback of snapping chocolate along a clean line. The environmental impact of chocolate bar design is also worth mentioning. The break line pattern affects how efficiently chocolate can be packaged and shipped. Rectangular grids pack more efficiently into boxes than irregular shapes, reducing wasted space and lowering transportation costs and carbon emissions. The ability to break chocolate into smaller pieces also reduces food waste. If you can easily break off just 1 or 2 pieces instead of opening an entire bar, you're less likely to let the rest go stale or melt. Some companies are now experimenting with break patterns designed specifically to minimize packaging material by creating bars that fit perfectly into minimal wrapping with no excess space. There's also ongoing innovation in this space. Some chocolate makers are using 3D printing technology to create experimental break patterns that would be impossible with traditional molding. Others are using fractal mathematics to design break lines that create aesthetically interesting patterns while maintaining structural integrity and portion control. There are chocolate bars with break lines that form pictures or logos when you arrange all the pieces together, turning the breaking process into a kind of edible puzzle. The simple act of snapping off a piece of chocolate involves far more complexity than most people ever realize. It's not just a random pattern pressed into chocolate for convenience, it's the result of mathematical optimization, balancing portion size, divisibility, manufacturing efficiency, structural integrity, and consumer psychology. It's engineering that ensures the chocolate breaks cleanly without crumbling or shattering. It's branding that makes certain patterns instantly recognizable. And it's decades of research into how people share, consume, and enjoy chocolate. Every time you break off that perfect little rectangle, you're experiencing the culmination of all this hidden complexity, a moment where mathematics, engineering, psychology, and pleasure converge in something as simple and delightful as a piece of chocolate. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution,